All right, so now on to tackling some of these CSRF labs. We're actually going to do about half of them in this video is the goal here. And yeah, we'll start out with the most basic one, just a CSRF vulnerability with no defenses. And that's something that you might be surprised how often you see that in the wild if you're a pen tester. But it would be the one of the lower cases. You wouldn't see it as much as probably some of these other ones we're about to tackle, but definitely a good one to know, the most fundamental one. So let's get right into it. We have credentials here that we can use, and our goal is to change the user's email address via a CSRF attack. So we're just going to go ahead and fire up this lab here. And the first thing we're going to need to do is log into his account. Get that active session, right? Because CSRF is an attack that relies on, attacking a user that has an active session. But the most important part is that we need to be able to determine what the request looks like when we reset the email. So I'm going to go into my account, and then let's see if I can make this a little larger for you guys viewing on smaller devices. Yeah, so if I use this username and password, able to log in if I do it correctly. Man, I am really struggling here. Hang on. Peter. I think I did it right this time. There we go. Okay, so I don't want to change it yet, so I'm just going to send the current email. Now, the reason I'm sending this request here is I got Burp fired up and logging this traffic. So now I should be able to see a post request. And this is what a valid post request to change the email looks like. Now, I'm using the community edition of Burp. If I was using the Pro edition, I could just go down here, engagement tools, generate CSRF POC, and I'd be good to go. Now, there's just a little bit extra because I'm using the community edition. I got to create it myself. And that's something that I've already done. But basically what you do is you have all your boilerplate HTML, and you add these form tags here, and the action will be the full path to the request here. So you could get that from both the host and up at the top here, you can get the full path. You add this and this together, and that's your full path. Now, in my case, I might need to switch this here to account for the box that we're working on. So I'll just copy, paste that in. And yeah, make sure you put HTTPS at the beginning or it won't work properly. And then I'm going to say method is post because we want to do a post request. And then I have these hidden input fields here. So the name would be equal to this value here, email. And then you just say that the value will be equal to the value of the email field, which is this. And keep in mind, it's doing some URL encoding here. You don't want to, when you put it in here, you want to make sure it's not encoded. Otherwise, you'll end up double encoding it and it won't work. So no encoding on the value here. And then you can close that out. And then you can have some JavaScript that will say automatically submit this, submit the forms. So that's what I have here. So if I copy all this code here, the way you actually pass these labs is that you need to go to your exploit server. So click on that. And then in the body, I'm going to put this in. Now, if you were doing this without the exploit server, what you would do is just host this on your local machine as I did earlier. And then you can go to that while you're logged in, and it will submit the post request for you. But in order to pass these labs, you just got to copy paste into the body here and then say deliver exploit to victim. So there we go. We got the congratulations, you solved the lab message, which is the target here. So basically they simulated going to our page and executing the attack. So that's pretty much all there is for the most basic attack. So the next one is, let's see here. Okay, yeah. So the next one is that CSRF, where the validation depends on the request method. So sometimes they explain here that sometimes it only checks for the token if it's a post request, but if it's a get request, it ignores the token. And we're going to be starting off with the same steps as in the previous one. We're going to just log in first. Hopefully do that on the first try correctly. Okay, excellent. And same thing, I want to see what the valid post request looks like first. So I'll send this. And now when I look at that, I see, okay, it includes the CSRF token here. Now, to test this out, what I can do, I can use the repeater first before we create the malicious HTML to do it. And what I could try to do is, let's change this to hacker at mail.com or something. So we have that. Now what we're going to do, we can keep this CSRF token here. Or actually, no, we can just get rid of it because we shouldn't need it. Now we right click and we say change request method, and this will change it to a get request. So when we send this, redirect, and let's look for our, okay. In this case, it didn't go through, it looks like. Let me just back this up. All right, up here, hacker at mail.com. Let's try that. So because it's a get request, it's up here in the URL. So follow redirect. And here we go. Your email is hacker at mail.com. So this looks like this is working properly here. Let's go back. And what I'm going to do, I think the reason it failed initially is it was double encoded because it was encoded up here. It will automatically URL encode it for you when you send it, so you don't want to double encode it on accident. And so the way you do the GET request, from what I found, is a little bit different. There might be a way to do it with the forms by changing it to a GET and massaging it a little bit to get it to work. But I found the easiest way to do it is, don't worry about using the forms for a GET request. Just simply, here, let me copy all of this here. Just simply use an image tag. So get rid of forms. So something like image source equals, and then you can have your payload there, and then close that tag out. And I just found that this was like the most simple way to do it. So if I copy all of this here and go into here, paste this, deliver to victim. Then we were able to solve the lab. So, I'm pretty sure there should be a way to do it with the forms, but I'm not 100% on that. The fact that we specified the method as post means get, I'm sure, is a method they could use. But yeah, I would just go with the image tag. It's probably easier when you're dealing with get requests. So the next thing is that, let's close out of this. And the next one they talk about is that the validation simply depends on the token being present. And so we'll start that lab. And essentially what they're talking about is there's some cases where if the token's present, it does the validation. If the token's not even there at all, then it doesn't even check for the presence of the token. It just says it's fine. So this one will be really easy to do. It'll basically be the same as the first one, because we'll simply submit the post request without a token. So let's see what the valid request looks like as usual. Get rid of that extra space. And going to proxy. You see this post request here. It has a token. So basically we just drop the token, right? And it's going to look the same, pretty much exact same as the first one we did. So let's just go back, and we have this here. Change this back to a post. And, well, let's see if we can go back even further, right, before we did this. So there we go. And we need to change the URL, of course, getting rid of this extra stuff and accommodating for our particular server we're using, which is this one here. So yeah, this looks about right to me. Let me just double check on the endpoint. My account, change email. My account, change email. Okay. Yeah, so this should be good. So what I'll do is copy this. We'll put this into the exploit server. In the body, and then we'll try to deliver this to victim. And we have solved the lab. Yeah, that one was pretty simple, pretty straightforward. Just don't include the token. So next thing is we will go after the last one that I'll cover in this video. Is the CSRF token is not tied to the user session. So what they're saying here is that you could be logged in on another account, grab the token, and just don't use the token for the request. So intercept with burp, drop it, and you can use that same token on the other session. Well, you can use it to attack the other user, right? Because the server generates a token, that token's not used, so it doesn't get destroyed, and it doesn't tie it to that user session in any way. So as long as the CSRF token is active somewhere out there, then you can use it for any user. So that's the vulnerability. And definitely one that I need to start checking for more. My real world testing that I do, most certainly. So we'll start up the lab here. So we got 2 accounts to demo this. So the easiest way is, this is why I have this tab here. We're going to fire up another one in our private browsing. That way we can have both sessions going at once. And on the first one, it doesn't matter which account we log into on either one. I suppose what I'll do is I'll log into this Wiener account here. Peter on this one. And then on this other session here, I'll log into the Carlos account. So Carlos Montoya. Hopefully I typed that right. I did. So the way I'll do that is I will get the a valid token from Carlos. But what I want to do is make sure that I turn intercept on over here. Actually, no, sorry. I'm going to get the valid one over here because I didn't set up burp to work in incognito mode. I don't feel like doing that right now. So, oops. I will go ahead and set intercept on here, and we'll see what the valid request looks like. So here's the valid request, but the most important part is that we grab this CSRF token and we drop the request. So we dropped it, and now we can turn intercept off at this point. And so what we'll do is we'll carry this attack out against Carlos. So if we carry this out against Carlos, we'll just fire up the exploit server over here, and then we'll account for this one here. So let's go ahead and put in an extra input field here, because if you remember, there's a CSRF token involved. So we'll mark it as hidden. We'll say name is CSRF, because that's what the parameter was called. And the value of that parameter will be the token itself. And now all that's left to do is to make sure that we have the correct server listed here. So we'll do that. And then everything else should be the same. Yeah. Okay. So now that we've done that, we'll go here. That's what we will paste in. So let me make sure I copy full thing here. Paste and deliver exploit to victim. Hopefully we can get this on our first try here. And looks like we didn't get it on our first try. And I just realized an error here. I didn't close out this input tag. So we'll make sure that that's closed out this time around. And let's try this one again. The curse of doing the demo, right? So we will deliver this to victim. And now we're able to actually solve this lab. So hopefully this helped you guys out understand some of the different ways you could go about trying to identify and exploit a CSRF vulnerabilities. There's definitely more that we could cover in a future video. But in the meantime, I do plan on checking out some of the other vulnerabilities that they have featured on here in the labs as well, of course. So if you're eager for some more technical content, go ahead and check out this playlist on screen now, what you need to know for OSCP. This will definitely help you. Some of these vulnerabilities you won't really see on there, the ones that are client side like CSRF, probably won't see on the OSCP, but definitely ones like SQL injection, XML external entities injection, a lot of the input validation based vulnerabilities, you will see those. So this could definitely help supplement that as well. So see you in those videos. Thanks for watching.